Welcome to Module 203E on Basic Hot Water Heating Systems. Now that we have a basic understanding of what a hydronic heating system looks like, let's take a closer look at the components. Many of the hot water heating components are similar to forced air heating components. For example, the main burner ignition devices. A lot of systems require a standing pilot flame that will have either a direct spark or an electronic ignition, which means that we need high voltage transformers and wiring. We can also use a hot surface ignition system, which would require 120 volts. Our systems also require flame-proofing devices in order to provide a 100% shutdown protection on the burner in order to prevent any unwanted gas buildup. We can use thermocouples, flame rods, pyrostats, or CAD cells, which are light-sensitive cells. So it's a photoconductive cell that changes resistance when exposed to light. Outside the boiler unit, we have zone valves, which are 24-volt hot water valves that are controlled by the thermostat. Some valves have an end-of-line switch to sequence other equipment. These are called auxiliary contacts, and typically we use these for the burner control. When we interlock the burner control, we can turn on the burners only when there is a call for the heat. There are many different configurations depending on what the application is, and we can combine these with circulation pumps. Typically, we have three different types of valves. The first type of valve is a two-wire power to open, which means the stat will only provide power to the valve on heating demand. The second type is a two-wire power to close. This means that the valves will be open when there is no power. In the case of a power outage, we would have circulation throughout the zones. However, this also means that we have to constantly feed power to the zone valves anytime that there is not a call for heat. The third type of valve is a three-wire power to open or close valve, and this requires a special thermostat. This will not change positions on power loss. So if we do lose power to a system, the valve will stay in the position that it is in until it is activated to either open or close. Every system also needs to have a circulating pump. At a minimum, we need to have a main pump. However, we can also have zone pumps, but these would replace zone valves. The purpose of the circulating pump is to create head pressure to circulate water through all of the different zones and sometimes through the boiler unit as well. Usually these motors are up to 1 horsepower and they're quiet and reliable. They can be either oil or water lubricated, and simple systems are single speed. If we have a multi-speed pump which would provide better heat control, we can use electronic controllers. These are either built as a continuous operation or an intermittent operation, and we have to be aware of which ones are which. The intermittent operation is controlled by the zone valve and switches. These are also typically interlocked with the burner, so the burner only fires when the pump is running. These systems have a number of specific safety control devices that are required by the American Society of Mechanical Engineers, or ASME. They provide codes for hot water heating systems. Some of the recommended controls are the low water cutouts, which contain a float switch that is interlocked with the burner circuit, and this can also be used to control a makeup water. When the float switch senses low water, the burner is disconnected and the water makeup control refills the system. We also have temperature control devices, and they come in two different types. First, we have the zone air temperature device, the thermostat, and there are specific types for different types of valves. We also have the boiler temperature device, which is controlled by an aquastat on the boiler. The aquastat can either be an immersion or a surface mount type and can be used for both high limit and low limit temperature control of the boiler. Lastly, we have the relief valve, and this is a non-electrical device, and it is a last resort safety device. If the system gets too much pressure inside, it is designed to release the water from the system in order to lower the pressure. You have now reached the end of Module 203E. Return to Blackboard and do the review test, and then continue on to 203F.